Greetings, I'm Professor K, and in this short video presentation we're going to take a look at the capture options for Wireshark. Now, very seldom will you have to deal with these capture options. Most of the time the default settings for the capture options in Wireshark will work fine for most situations. But if you need to make adjustments to the capture options, there are one of two different ways that you can get to that dialog box. First, you can go up here to the taskbar and you can click on capture, and from there you can access options. The second way is to go down here to the toolbar and click on the capture options icon. Once you're inside of the capture options, you'll note that we have three different tabs we can look at. Our first tab is the input tab, and this contains all of the different interfaces that are currently attached or assigned to your Wireshark. The first column contains the name of the interface, that's right here. The next column is the traffic column, and this shows any network activity that's currently happening. This little squiggly line here is the network traffic, and that is called a spark line. The next column that we look at is the link layer header. This is where we're given the type of packet that is being captured. For instance, on my Ethernet 0, I am capturing Ethernet packets. Our next column is promiscuous mode. Now, promiscuous mode is the process of allowing the interface to capture all network traffic that is passing through its interface. Without promiscuous mode, the only network traffic we're going to capture is the traffic that is destined for that interface by default. So, for instance, if I'm in a public area and I want to monitor all the other users that are currently using that same network, my adapter must be in promiscuous mode. By default, when we enable promiscuous mode on all interfaces, this automatically configures all of our interfaces for promiscuous mode and overrides any other settings. Our next column is a snap link. Now, what this does is restricts the amount of data that can be captured for each packet, and it is adjustable. All you have to do is just click on it, and you'll see that that is the default size that will be captured for each packet. Our next column is the buffer column. This is the size of the kernel buffer that is reserved for capturing packets. You can increase or decrease this as needed, but the default is usually sufficient. Our next column is monitor mode. This allows you to capture full raw 802.11 headers. Support depends on the interface type, the hardware, the driver, and the OS. Note that enabling this might disconnect you from your wireless network. The last column is the capture filter column. Here you can take your interface and you can assign it to a default filter type. By just double clicking in here, you'll notice I can now add a default filter such as port 80 or HTTP, FTP, or whatever that filter might be that I want to assign to this interface. Back at our interface column, if we take our mouse and we just hover it over any interface, we will be shown the IP address along with the MAC address for that interface. Down here at the bottom, we have that box to enable promiscuous mode on all interfaces. If this is checked, it will override the default settings for each individual interface, as you see. The capture filter for selected interfaces allows you to assign a default filter to more than just one interface. Clicking on the compile BPFs opens up the compiled filter output dialog box, which shows you the compiled bytecode for your capture filter. This can help to better understand the capture filter you have created. Our next tab is the output tab. The capture to a permanent file allows you to specify the file name that will be used for the capture file. It is left blank by default. If left blank, the capture data will be stored in a temporary file. You can also click on the button to the right of this field to browse through the different files and the file system. The output format allows you to select the format of the capture file. PCAP-NG is the default and is more flexible than just PCAP. PCAP-NG might be required if more than one interface is chosen for capturing. Checking the box to create a new file automatically sets the conditions for switching a new capture file. A new capture file can be created based on the following conditions: the number of packets in the capture file, the size of the capture file, the duration of the capture file, and the wall clock time. Our next tab is the Options tab. I recommend that unless you know exactly what you're doing in here, that you leave the default settings as they are. Checking the box for the Update List of Packets in Real Time updates the packet list pane in real time during capture. If you do not enable this, Wireshark will not allow any packets until you stop the capture. When you check this, Wireshark capture is a separate process and feeds the captures to the display process in real time. Checking the box to automatically scroll during live capture allows the user to see new packets as they come in, so you are always looking at the most recent packet. If you do not specify this, Wireshark adds a new packet to the packet list but does not scroll to that packet in the list pane. This option is grayed out if Update List of Packets in Real Time is disabled. If the box for Show Capture Information during live capture is checked, the captured information will be shown while packets are captured. For name resolution, by default, Wireshark will resolve MAC addresses. It will also resolve network names to a network address, and you have the option to resolve transport names to port numbers. You also have the ability to stop a capture automatically after a certain condition is met. Checking the boxes in this field allows you to tell Wireshark to stop the capture after so many packets, so many files, a certain size has been reached, or after so many seconds. Again, it should be noted that most of the defaults for the capture options will work fine for just about any type of capture you want to perform. And so in this short video presentation, we got to take a look at the capture options available to us up inside of Wireshark. So if you have any questions or concerns, don't hesitate to reach out, contact your instructor, and I'll see you in my next video.